Okay, so 4.5 is solving systems of inequalities, and you actually did some of this. If you were in Math 60 last term, you did some of this exact same thing, except instead of having two equations, you just had one. All right. So I don't exactly know how you were taught that. So I'm going to show you a couple different ways. I'm going to show you the way I kind of like to do it, and then I'll take a guess as to what maybe your instructor did. So let's take a look at, okay, so what is this? What does a system of inequalities look like? Well, they look like this. So if we have 2x minus y is less than 6, and x plus y is greater than or equal to negative 3, all right, that's called a system of inequalities because it has our little inequality signs. This one, remember, means less than. 2x minus y is less than. The mouth always eats the biggest thing. And x plus y is greater than or equal to, because it has this down here, negative 3. All right, so my guess is that, before you just had this part here, or this part here, and you graphed it, okay, and then you shaded. So you might remember that. So you're going to do the exact same thing here, is we're going to shade, all right, we're going to graph and shade. So I'm going to take this one, right, and if we're going to graph it, we have to solve for y. So I'm going to get y, I'm going to just go negative y, is less than negative 2x plus 6. Now I don't want a negative y, all right, I want a positive y, so then I'm going to get rid of that negative. But to get rid of that negative, a whole bunch of stuff's going to change. So we have that, we have this has got to change, this has got to change, and this has to change. So we flip that around, we have a 2x and a minus 6. Whenever you divide by a negative, your inequality sign is going to change. So it's going to flip. All right. Then let's do this one in, here we'll do this one like in a purplish color. I want to separate them out color-wise. There we go. So here I'm going to subtract x again. So we have y greater than or equal to negative x minus 3. So here's one equation, and here's the other equation. So now we're going to graph those. Okay, so I'm just going to graph them. Okay, so I'm going to graph the green one first. So I have negative 6. So that's my intercept. 1, 2, 3, 4, 5, 6. And plus 2, so 2 over 1, 5, 4 over 1. All right, and since this is a less than or greater than either one of those, is going to give me a dashed line, meaning that it doesn't contain anything on that line. So I'm going to dash the line, put a little arrowhead on it. Okay. Now, since it's an inequality, that means that it takes this coordinate system and divides it in half. So either the answers are up here or the answers are down here. Okay? So, depending upon your instructor, they would have maybe approached this in a couple different ways. One is that they would say, well, you're going to choose a point on either side of the line, and most of the time they probably told you to choose 0, 0. Okay, because 0, 0 is here. All right, and then we're going to take 0, 0 and put it into the green equation there. So I'm going to have this, 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 and then I'm going to put 0 into both of these things. obviously 2 times 0 is just 0. So I have 0 is greater than negative 6. Okay? And that's a true statement. 0 is greater than negative 6. So then I would shade up here. All right? So that could be one way that the person may have taught that. Okay? What I do is I tell people, well, you should just kind of read this and see what it says. This says that y is greater than 2x minus 6. So if it's greater, then would it be shading above the line or would it be shading below the line? If it's greater, which way is it going to shade? Above. So then you would shade above. All right, so you don't have to put a point in. You can just read it and say, well, what does it exactly mean? It says y is greater, so that means I got to go above the line. If it's less, then I would go below the line. All right, so it depends on who you, what your instructor's tendencies were, I guess. All right, on this one, same thing. I'm going to go to negative 3, 1, 2, 3. Okay, and then my slope is a negative x, so it'd be negative 1 over 1. So I guess I'll go down 1 over 1, put a dot right there, right about where this one is. This one has greater than or equal to, okay? So in this case, I do shade with a solid line, or I draw it with a solid line like that. And then again, you could pick a point, right? Or you could just look at it and say, well, this says y is greater, so then when I shade above or below the line, which way? Above, right? So then I would shade above and I get this real mess, okay? Well, the real mess is the answer to this. So where these shades overlap, that's the answer. So you can't write anything down on these. All you can do is shade them, okay? You can't solve them by substitution. You can't solve them by elimination. All you can do is graph them, and there it is, all right? So you're just looking for an intersection of where the two shades overlap. All right, so you have to graph them. In other words, there's just no other way around it. All right, so let's try another one here. Let's see, I think I was using this. So let's go with 3x plus y greater than or equal to negative 4 and negative 2x plus y is less than or equal to I think I'm going to make this a positive 4 instead, so we'll get rid of that. And then negative 6 maybe? Okay, so let's try this out. All right, so again, we're going to have to graph these. All right, so I'm going to solve them for y. So let's see, I'll do this one this time. And what is this? This is a brown. So do it in brown. So I'm going to move the x over. So we have y is greater than or equal to negative 3x plus 4. So there's that one. And let's see, maybe I'll do this one in orange. So we have 3y less than or equal to positive 2x, because we're going to slide that over, minus 6, but I can't have a 3 there. All right, so I'm just going to divide by 3. All right, and then I'm ready to graph here. Okay, so we'll do the brown one first. I think that's this color, or maybe it's this one. Yeah, good. Okay, so 4, 1, 2, 3, 4, right? Slope, negative 3 over 1, down 3, 1, 2, 3 over 1. Solid line, because I got an equals to. All right, y is greater, so which way are we going to shade? above. And above's going to be up here. Okay, there's my above. All right. Then I got this orange color here. So let's see. Now I'm going to graph this one. So 6 divided by 3 is 2. So that's negative 2. Okay. Slope is 2 over 3. So go up 2 over 3. Solid line. There it is. All right. And then it's y is less. So which way do I shade? Below. Okay, so it's going to be down here. So then I don't have enough brown here to complete it. So there's my region. Okay, right there. We're always just looking for that region. So let's do one more. Any questions on what we're doing so far here? The first one was like one of the examples, and the second one I made up. They might have something like this, where you have x is less than or equal to like a 2, and a y is greater than or equal to a negative 1. If they have something like that, so then we'd have x is less than or equal to 2. So x2 right there. So we'll do that one in green again. So that's going to be a solid line right through 2. Okay. X is less. Which way would we shade? Now you can't. It's hard to use above, below in this case, but we can use left or right. So which way would we shade? Do you think? Left. Very good. Because this is all less, right? All these numbers are less than 2. So that's the way I'm going to shade. Let's see. Then we have y is greater than 1. Negative 1. So that's going to be down here. Solid line. Okay. We can still do the same thing here, though. So y is greater. So which way are we shading? Above or below? Above. So then there's my answer where that pinkish fuchsia green comes together. All right. So you might have something like that. If you do, it's not a big deal. You just kind of graph and shade them. Okay, there's just no diagonals.
So then the answer is like infinitely in that area?
Yes.
So how would you write the answer down? And would it just be like a set of all x and y is?
The graph answers it.
So you would be able to answer it with an actual equation? Okay.
No. Any point in this region is an answer. Okay.
So would it be okay if I, with a question like this, if I did them on graph paper, would that be okay?
Yeah.
Yeah.
Sure.
That'll make it easier.
Graph paper, yeah, if you want some. Yeah. Okay. Now, nobody has said anything about, does Desmos graph this? Guess what? It does. Okay. So I'll show you that it does. And how it works, so you can check that out. So let me go into this, and no thanks. We're just going to go here. Here we go. DESMOS. Alright, so then we'll do this. So here's how it works. So you just got to type them in, right? So let's go back and we'll do that first one. So the first one was 2, so 2x minus y. And here's all your less than equal to keys right here. So I'm just going to go less than 6. Okay, look at that. Shades it like that. Pretty cool, huh? And then you come down here, x plus y greater than or equal to 3, negative 3. And there it is. Okay, so the answer is this shade right here. But the only way you can really answer that is to sketch it. So you would just take your paper, go like this, draw a line, dash this, and then shade that. Okay. So Desmos will graph it too. All right, it understands inequality graphing. It's pretty slick. All right. So you can do some of them that way too. Okay. I mean, you probably know how to graph things by hand. I mean, you know how many of those you got to do to. I'm sure you probably know that, but you should be able to do some of them on your assignment by hand, just so you know how to do it that way. Okay. But then also, if you want to use Desmos for some of them, you can too. Okay. That's pretty much all of the that they have here. I don't think there's anything else I can look and see. Where's the over here. 33.
I have a question on the second example. So it's 3y is less than or equal to 2x minus 6, and then you
Let me get it here. So you're talking about. So what is it exactly?
the second example.
Uh huh.
The one that you just did is what's the.
Oh, the one I did. This guy right here. Uh huh.
So how'd you graph it? I didn't really understand that.
Okay.
What did you do with the 3?
So I took this equation here, right?
Yeah.
Okay, and here's my 4, correct? Okay, so 1, 2, 3, 4 is my x-intercept,
Yeah.
or my y-intercept. Okay, slope is rise over run, right?
Yeah.
So it's negative 3 over 1. So I went down 1, 2, 3
Okay.
over 1. There's my line. Same thing on this one. So I went negative 6 divided by 3.
Oh, okay.
So that's negative 2.
So the 3 does nothing to the x then, right? Or does it?
You mean like in this case?
Yeah.
So it's just 2 over 3 is your slope.
Oh, okay.
So then I just went up 2 over 3.
Oh, okay.
Yeah.
Okay, so the 3 kind of replaces the x. Okay.
Other good questions? That's pretty much all there is to that. I can do some more if you want, but like I said, you probably did some of those same things. And they did one of the tougher ones right off the bat. Some of them are already solved for y. I don't know, do you see anything on 339 that you're not sure about? We're going up to 33, I think it is.
Number 33.
So 33 says 0, x, 3, and 0, y, 3. Okay. This one, I don't think Desmos will handle this one. Okay, so let's look at this x one, right? So it's 0 to 3, correct? All right. So if I just broke it in half, so I broke it like this, okay, I would draw a vertical line right here at 0. Does that make sense?
Yeah.
Okay. And then if I broke it in half like this, I'd draw another vertical line at 3. Does that make sense? Okay, so let's do that then. So I'm going to draw one. Let me go like in a black here for this. So we'll go here and here. Okay, the question is then, what would this shade look like? So if x is greater than 0, less than 3, that means that I got to shade
Just that area.
that area, right? Okay, so if I shade this area, okay, now let's do this other one in this little purpley color here. Same idea, we'll split it in half, right? So we'll go like this. So then we have y greater than 0 and y less than 3. So we draw a line here at 0 and here at 3, and then where's the shade going to be? Right.
That's a lot easier than I expected it to be.
So the answer then is this little box, right? This square here. Mhm. That's a good question, though. Anything else in that? Okay, so we're going to be fine time-wise. All right, let's do this. Okay, so what I want to do is talk about your activity thing here. Okay, what it's going to look like. And the good thing is this is being recorded so you can refer to it. Hopefully. Sometimes I have to reset this pen here. Oh, good. All right. So here's what's going to happen. So what I'm going to do is, so I'm going to take you through a step of a problem. It's going to look like your activity. What it does is it gives you an application for where this would be used. Okay, so that's what I want to try to do, is give you some application stuff on this stuff once in a while. So you're asking, where in the heck would somebody use some of this stuff? But this idea is used in certain applications of economics and nutrition and where else? Economics, nutrition. Some type of probably computer engineering things. So it does have some sort of application. Okay. Let me give, I got to go back up here and steal some information I wrote down earlier today. I think it's in this one. Yeah. Okay. So here's what we got. I have a meal. So someone is interested in eating some bananas and a blueberry muffin. Okay, so in this bananas and blueberry muffin diet, okay, here's some information. So we have bananas. If you ever want me to slow down, just say something. Have 20 calories, that's per banana, and 2 milligrams of sodium, and 422 milligrams of potassium. I looked this stuff up. So it's pretty real. I fudged it a little tiny bit in a couple spots so that the equations would turn out nicer. But otherwise it's pretty real. The blueberry muffins have 426 calories. And 383 sodium, that's milligrams. And 130 potassium. And that's also milligrams. Okay, All right, so here's what we're doing. So we're eating bananas, blueberry muffins. Okay, our bananas have 20 calories, 2 milligrams of sodium, 422 milligrams of potassium. Blueberry muffin has 426 calories, 383 milligrams of sodium, and 130 milligrams of potassium. That's for one muffin. All right. So if we wanted to say we want to minimize, oh, actually, sorry. We want to have no more than, I hope I wrote that down, 800, I think it was. No more than 800 calories and no more than, let's see, the other one was sodium. Dummy me didn't write that down. Okay, I'm just going to have to take a guess at it. And no more than 700, I'll say, milligrams of sodium. Okay, how many servings of bananas, oops, and muffins to maximize potassium? Okay, so crazy question this is. All right. So again, we're eating blueberry muffins and bananas, and we have all this information we have to sort through. All right. This person's on this special diet thing, and this is just an example, right? Where they are interested in sodium and calories and potassium. Okay. So they want to meet certain restrictions or meet certain limits on the calories and the sodium, but they want to maximize the amount of potassium they're getting. Maybe they have a potassium deficiency or something like that. So they want to maximize that. All right, so first thing we're going to do, all right, is write some objective, or excuse me, some constraints. And constraints are just the inequalities. Okay? So, to make things kind of simple, we've got the bananas and we got the muffins. So one of these should be X and one of them should be Y. You guys got a preference on which one you want to be X or Y? Okay. All right. So, constraints or inequalities kind of define the problem. If you need me to stop, too, just say something, right? So constraints and inequalities are kind of the same thing. They're going to define the problem. They're going to give us the region that we're looking for. All right? But there's one constraint or inequality that's not even mentioned in this problem, but it's assumed to be true. And that is that X and Y are greater than or equal to 0. Because it wouldn't make any sense to have a negative number of bananas or a negative amount of muffins. You know, I mean, you're eating these things, you're not, throwing them up, right? So you're eating them, all right? So you're not going to have negative amounts of stuff. So that's why we write these. These inequalities are going to almost show up every single time. All right? So in your thing, which breaks it down, by the way, it breaks down the step by step. That's going to be two inequalities that you're going to have also. Okay, so there's that one. Now let's go up here and we see we have some common things. So for example, I see I have calories for bananas, I have calories for muffins, and I have calories there. Okay, so I want to write an inequality that relates all of those things because they are all the same category. So if I come down here, I can say, okay, I've got, let's see, 20 calories in a banana. So then I'm going to write 20x plus 426y. And I said I can have no more than 800. So what inequality sign would I put there? Exactly, less than or equal to 800. So there is another inequality or constraint, right? So I got these two, and I have this one. Okay, so that's what you want to do with yours too, is you want to sort through the things that are like. Okay, look for those items or quantities that are like. Okay, so there's that. Then we have what else? Let's see, we have sodium. So we have 2 milligrams of sodium there. I have 383 milligrams of sodium there. And I have no more than 700 milligrams of sodium there. So let's write one for that one. What would that look like?
2x plus 383y greater than or less than or equal to 700.
Okay. All right. That's it. Those are all the inequalities we're going to have. All right. So what we want to do now is graph it, right? So we want to graph this and get a region. Okay. Now I would not graph this one by hand because look at those crazy numbers. You know, I looked this stuff up. There actually is 383 of whatever the heck that was in a muffin, okay? Because this is real numbers, and in a real situation, you're not going to do things by hand like that. So we need to solve these. We need to put this into Desmos and graph it, all right? So I'm going to switch out of this for a second. This is the part you're not going to see, unfortunately. And put these in here. So I'm going to get rid of this guy, get rid of this guy. All right, so the first one. Now, I can put in the x and y's less greater than or equal to 0, but it might kind of make the graph look a little messy. So I'm just going to put the 20x plus the 426y is less than or equal to 800. Okay, so there's that. All right, now I'm going to put this one in. I might have to, I can't remember what I used for this, so hopefully this works out. Yeah, it's not very good. I wonder if I should try 6. No, 6 isn't too bad. Maybe we can get it to work. Well, let's leave it at 7. I think we can get it to work there. Maybe. Now we better change it to 6. Sorry. So we better change that to 6 for simplicity cases. Okay. Now, so this doesn't look like anything very much at all. All right. I definitely have a region here, but I really don't see it very well because my window isn't quite correct. Okay. Here's the 0, 0. So remember, that means we don't worry about anything here, these things. We don't even worry about this stuff. We're only focusing on that. So what I'm going to do is change the window dimensions. And you know, you can do whatever this is called, okay, on your phone or whatever. What I'm going to do is go to the graph settings, click on that, click on this by the way so you can see things a little better, and then I'm going to put in what I want for x and y. So for x, I want that to be 0 because I'm not going to have anything less than that. And 13.554 is not cutting it. I need something way out there. Okay, so I'm going to try 50. For y, I'm going to go 0. And then I don't have to go very high on my y because I can see things, so I'm just going to go about 5. and click here and see what I have. Now, whenever you change this window here, okay, it's going to change. Now your settings are different, but that's okay. We've got something here we can work with because we have this line coming down, that's the green line, and the orange line here, and now I have a region, right? Here to here to here and to here. So this is where all my answers are. All right. So one of my possible answers is right here. I don't know what that is. Let's see, that's a half of y, half a muffin and 10 bananas. Might make you sick, but that's an answer. Okay. 1 muffin and 10 bananas is an answer. All right. No muffins and 30 bananas is an answer. Okay. So these are all answers, right? That's what you were saying before, Thomas, right? You're saying, how do I do that? Well, the neat thing about this whole idea here, I'm going to switch back to this guy now and draw this on here, okay, is that there's something called linear programming, okay, that helps me out. Let's see if I can sketch this correctly. A little bit anyway. So it's like this. All right. And this is called, this whole process is called linear programming. Okay. And what it says is that you don't have to worry about anything except the corner points. The answers are always going to lie at these corner points. Okay. There's a mathematical principle called the corner point principle, and that's what it says. We only need the corner points. We only need those. All the rest of those points are meaningless. They're not going to give me the answer. We only need the corner points. So when you get down to you have equations and you've got a region, you should be pretty darn happy because all you need are these corner points. And that's it. And you're ready to go. Now, there was one other part of this, okay, that we're forgetting, and that is that we are trying to maximize potassium. Okay? Our overwhelming problem is we're trying to maximize potassium. We never even did anything with potassium, so let's do something with that. Alright, so let's see what we got here. We got 422 milligrams of potassium and 130 milligrams of potassium. So I'm going to come down here and write down my objective function, it's called, and it goes like this. Let's see, how much potassium is there in the bananas? 426? 22, so it'd be 22x plus, how many did we get on the muffins? How much? 130. Sweet. Okay, so there we go. 130y equals potassium. Alright? That's what I'm trying to get. Okay? So, that's my objective to this whole shooting match. So if I go down to right to here, alright, I want to check every single one of these corner points into this equation to check to see which one is a maximum. Alright? Now, we can pretty much figure out this corner point has what's its coordinates right there? 0, 0. Okay? Is that going to maximize anything? No. We don't even need to check that one because I'm not eating anything there. So that's not going to maximize a darn thing. Alright? This point here, okay, this point, I don't know what the y is, but I do know what the x is. Okay? The x is going to be 0. At this point, I don't know what the x is, but I know the y is 0. And this point is the important point because you can find that point by 3 ways. What's one of the ways we can find that point? We learned them. Substitution,
Addition.
elimination, and graphing. Okay? So you get to pick which way you want to do it. I know which way I do it. Which way you're going to do it. I'd use a graph because look, just kind of click on it. There it is. Okay, 7.4 and 1.5. All right, that's all you got to do is click on it. So 7.4 and 1.5 is that corner point. Okay, so I'm going to go write that in right now before I forget. 7.4 and 1.5. Okay. Now I can find this corner point too. Notice that. Oh, look at that. Tells me what that is. 1.5. Rounds up. I guess we can make 1.6. It's a little bit higher. And maybe it'll let me give me this one. 40 and 0. Okay. So now that I know those points, all right, I'm going to go back to this now. I can figure out which one of these is going to maximize my objective function. Well, I can tell right now which one's going to maximize it, but I'll run through it anyway. 0, 0, I'm not going to run through, so I know that's not going to work. So I'm going to go 422 times 0 plus 130 times 1.6. See what that is. Okay? Then I'm going to go 422 times 7.4 plus 130 times 1.5 and see what that is. Then I'm going to go 422 times 40 plus 130 times 0 and see what that is. Well, I know what the maximum is going to be. Alright, obviously it's going to be whatever this one is. Alright, but that's eating 40 bananas. Oh my goodness. That's a lot of bananas. But that's how the problem works. You know, I just used the real numbers, so you know, I don't know how realistic it is, but that's where it comes from. So once you check these out, so 130 times 1.6. Here, I'll just use my calculator on here. 130 times 1.6. 1.6 times 130 equals 3,000. What? Really? Something went wrong there. 1.6 times 130. 208. Okay, that's that one. Clear. 422 times 7.4. Gosh, that darn decimal point just doesn't want to hit. Okay, plus, I don't know if this is going to, well, it might work, plus 130 times 1.5 equals 317, I think it was, 0.8. Okay, so that's that one. And then my last one here, which I know is my answer, 40 times 422. That's a lot. 16,880. Okay. All right. So that's how this is used. Okay. So I mean that's kind of it was a little bit of a nutrition example. Came out to be kind of weird for the final answer, but you kind of got the idea. So yours is going to be a nutrition one. And so it's going to be very, very similar to this. All right? So you just kind of got to look for those things that are... Ooh, things that are in the same category: calories, 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 sodium, 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 and then the potassium was what we wanted to maximize. Once you write your equations, those constraints, make a graph. I would do it in Desmos. Don't do it by hand because those are going to be messy numbers. All right, come up with a sketch your little region, corner points, click on them to get those, and then put them into your equation, and it's a done thing. Everything is stepped out for you though. Okay, so it's not all one big mess, kind of like this one is. All right, kind of a lot. I know it's a lot, but it's recorded and you can look at it. I don't know, do you have any real general or specific questions you want to ask me? It does give you an application, okay, for where some of this is used at. All right, so let's take, this would be a great, yeah.
Where do we find the activity?
I'm going to give it to you. Okay, I'll hand it out. And I'll also put it up on the DTL site, so it's up there too. Okay? Yeah. All right, let's go ahead and take a break, and we'll come back and do... So 5.1 is about adding and subtracting polynomials. Adding and subtracting polynomials. Okay, so first of all, let's talk about what is a polynomial. Okay, poly means many, nomial means terms. So a polynomial, okay, is, it's easier to actually give you an example rather than to write some down. So let's do this. So 3x plus 1 is a polynomial. 2x squared minus x minus 4 is a polynomial. 3x cubed plus 2x squared minus x plus 1 is a polynomial. Anything that has a combination of x's, okay, with nice real numbers here, okay, those are all polynomials. It could just be a number. 4 is considered to be a polynomial. Okay, so all those are polynomials. So you might say, well, what is not a polynomial? Anytime you have something with a square root, with an x or this, okay, those are not polynomials because this is what we would call a function and this is a rational expression. So these are not polynomials. Okay, those are not polynomials. All right. So the thing with polynomials is that they have what we would say terms. Okay, so the terms would be, in this case, this has 2 terms, 1, 2. This one has 3, 1, 2, 3, 1, 2, 3, 4. Okay, those are your terms. All right. It also has something called a degree. And the degree is the highest power in the polynomial. Highest power. So we would say that this first one is a first degree polynomial because the power on the x is 1. The next one is a second degree polynomial. Okay, and the next one's a third degree polynomial. Now, most of the time, this one's not called a second degree polynomial. It's more likely known as a quadratic. That's what it's mostly called because it has an x squared, so it's called a quadratic. All right, but there are times when they are called second degree polynomials. After 2, they sometimes call this one a cubic, but it is pretty much known as a third degree, and then fourth degrees and fifth degrees and so forth. Okay, so that's the degree. All right, now I'm not going to ask you what the degree is of a polynomial. I figure that we'll be using that terminology enough that you'll kind of catch it, and I'll know if you know it or not. Okay, so if I say, well, that's a third degree polynomial, you say, oh, okay, because it has a highest power is 3. All right, since this high power here is 3, that makes it a third degree. All right, so I'm not going to test you on that. But I think they might ask you some questions about the degree of the polynomials. Okay, I see also that they ask about monomial, binomial, and trinomial. So mono means 1, so this would be a monomial. Binomial means 2, so this would be a binomial. And trinomial means 3, so this would be a trinomial. And I don't know if I've ever heard anybody say anything about third degree ones with 4s. They don't call it a quadromial, never heard that. So, and again, I'm not going to ask you about that stuff. Okay, I mean, we'll probably use some of this terminology. We see, well, it's a monomial, binomial means 2. Okay, trinomial means 3. When you get this, I think it's 6, chapter 6, you'll be using that stuff so much that you won't even know that you're using it. So I'm not going to test you on it. It's not worth the time. All right, but that's just some stuff on polynomials. Questions on the degree or the names? Okay. What we're going to do is just add and subtract them. Okay. So I'll show you how this works. You're not going to have any problem with this whatsoever. So if we have 3x squared minus 4x plus 1, I'm going to put parentheses around it, plus 2x squared plus 3x minus 4, put parentheses around that. These are 2, okay, second degree polynomials. Right? We're just going to add them. All right. To add these, you just add the like terms. So 3x squared plus 2x squared. We'd add that up. Going to give us 5x squared. Okay, we're not going to add up the powers because that's not how this works. We have a negative 4x here plus a 3x. Add those two things up. That gives us a negative x there. And we have a plus 1 and a minus 4. So that's a negative 3. So what I like to do sometimes is just kind of do something like this with the like terms, okay, so that you can see it. And then maybe that kind of thing. So I'll draw little shapes around them so you can kind of get the idea of what we're doing there. But that's all we're doing. It's just adding up the like terms. Okay? Nothing too exciting here. We're just going to do that. They will put some y's in there, so we better put a y in here just so that we have one. So you can say, oh, okay, we got a y there. All right. Here's the next one. Again, I'm going to add up the like terms. So there and there and here and here. Okay. So 12y squared plus 3y squared, what's that going to give us? 15y squared, yep. Now notice that I don't have a y here, okay? But don't worry about that, I just don't have any. So I just bring this one y that I have from over on this side, put it right there, and now I'm going to combine these two, so it'd be minus 1. Right? And there's my answer, okay? And you all know that you can't add any of these terms because these are unlike, right? 15y squared plus y, they're unlike terms. You can't combine those, so you leave it alone. All right. Here we'll do a subtraction one. 8x cubed minus 10x squared minus 3x plus 1. Now I just put these in parentheses to separate them out. and then 5x squared minus 2x minus 3. Okay, so here again, I have an x cubed here, but I don't have anything over on this side, so I just bring that down. I don't worry about it, and now I'm going to combine my like terms. So I got this one here, okay, I have this one here, I have this one here, and this one here, and these two, okay. So here we go. Now I have to be careful on this one, alright? So I got a negative 10 here, alright? And you can do this one of two ways, okay? You can take and move this minus inside. So this minus will go inside to here. So you'd have minus 5x squared plus 2x plus 3. You can do that and then just add them, okay? Or you can just simply subtract, okay? So what I would do is just say I got negative 10x squared here minus 5x squared. So that's going to give me a negative 15x squared. So I'm going to put that right there. Okay. Now I got a negative 3x minus a negative 2x. So now I have to think about that. See, a minus a negative, that's going to change into a positive. So I got a negative 3 plus 2. So that's going to give me a negative x. All right. And then I got a 1 minus negative 3. So that's going to change to a positive. So it's going to give me a plus 4. All right. And there's my answer. Okay. Notice you're going to get the same thing if you distribute the negative through. Okay. So we have 8x cubed minus 10 minus 5 minus 15 minus 3 plus 2 negative 1 minus plus 1 plus 3 negative plus 4. So you're going to get the same thing. Okay. It all kind of depends on which way you want to do it. I don't really care. You pick the way it works for you. You got to do that. You got to pick the one that works for you. All right, so let's see. I'm going to do one more and then let you do a couple, I think. So let's go with one more here. 4x cubed plus 2x squared minus x minus 2. I'm going to make this another minus. Okay, x cubed minus 3x squared plus x minus 1. All right. Okay. All right. Again, I'm going to combine my like terms. There's that guy. There's that one. Here's this one and this one. And let's see. This one and this one. And now I've kind of run out of shapes I can use, but I have plenty of colors, so we'll do one in pink here. This one and this one. Okay, so here we go. I'm going to write this out. So we got 4x cubed minus 1x cubed, so that's going to be 3x cubed. And again, you could move that inside if you want to. You pick your way. 2x squared minus a negative. Minus a negative means a plus. That's going to give me a 5x squared. Minus x minus x. That's 2 x's. Minus 2 plus 1. So that'd be a minus 1. Okay, and there's my answer. Alright. So you pick the way you want to do it. If you want to distribute this minus through, just make sure you go through to each and every one. Okay? And then add them. That's fine. You pick the way you want to do it. As long as you're getting them right. Doesn't matter to me. Now on this page 354, okay, they wrote some of them in what we call a vertical format. The deal is, the only book I've ever seen it does that is this one, okay? So I didn't give you any in vertical format because this is like one of the only textbooks that ever does vertical format. I mean, you know, if I looked at some of our algebra books at high school, they wouldn't write them like that. So they're all written in the way that I did it and the other way on here. So I didn't give you any problems in vertical format, okay? I kept it all like this. Any questions on this? It's pretty straightforward, huh? I mean, you're just combining like terms, right? Okay. They have some fraction ones in here, but you know, you just gotta grind through them, I guess. All right. Here, just for kicks, let's just do a couple of these. All right. Let's see. So on page 354. All right. So here's a couple off your assignment that you can work on, just so I feel good about knowing you know what you're doing. 9 through 32. So I don't know. How about number 20? How about 30 is a good one. And what about a -1? That's over in this section. Let's see, that was 55 to 70. How about 65? Okay, try those ones out. All right, those will be part of your assignment. And in about 10, it probably won't even take that long, but we'll go about a little over 5 minutes. We'll see if you got answers for them. Okay.